One of the common mistakes that I see software developers make is actually going with an event-driven architecture when they should instead stick with a synchronous standard pattern. To help you with that, I'm going to give you a really important and interesting decision tree that you can use to ask yourself these questions and then decide whether you need an event-driven architecture or whether you don't. Now, in this case, I'm going to show you some useful diagrams here and hopefully you're going to come to a decision. So the first question is whether the caller needs an immediate response or whether the user is actively waiting. So examples of this would be, for example, in an e-commerce website, when you are going to a checkout and the sum of the items have to be calculated. Or for example, when you're authenticating a user on your website, obviously the faster you do it, the better it is. Or for example, the user searches for some items on your website. Obviously, you don't want them to wait for too long. In this case, you should go with a synchronous pattern, meaning one of the services is going to call a different service and expect a result right away. And we don't want to wait for too long. Now, examples that are not in this ballpark are actually sending an email. An email can be sent a bit later. It doesn't have to be right away. Also generating a PDF, unless it's the actual product that you're providing. Or for example, updating the analytics. All of this is secondary and can be done after a bit of a delay, right? It doesn't have to be right away. Now, one of the things that I hear a lot is that you cannot combine the synchronous architecture with an event-driven architecture. And I believe this is a mistake. Part of your application can actually be synchronous, or let's say most of it, and some small amount of it can actually be event-driven. For example, in an e-commerce website, all of these things can be synchronous, but sending out an email after the purchase has been made can actually be asynchronous. It can be an event-driven. But you remember that as soon as you introduce an event-driven architecture into your stack, you're going to have to deal with some intricacies along the road. I'm going to talk about those in a minute. Now, the second important question is whether your event needs to trigger multiple independent downstream actions. For example, if this service is only talking to another service here, then you only have one downstream service that you're talking to. But if there's another service here that this service also has to independently call, meaning these two services are actually not really connected, then you can do this in a fan-out pattern. And this is called fan-out because you're basically fanning out one action into multiple places. Now, a fan-out in this case would ideally be working with a message bus. For example, if you have Kafka, or whether you have RabbitMQ, and this is one of your queues, one of the services is going to put the message to the message queue, and another service or multiple other services are going to be subscribing to a specific topic and then are going to be notified when this message ends up in a message bus. And this is ideal, for example, when a user signs up, you want to send a welcome email. At the same time, you can start a trial subscription, do something with analytics, and add this user to a CRM. All of that can actually be done in parallel, and this is called a fan-out. Also, does the services involved process data at a different rate? For example, if your API can accept obviously more users, 10K requests per minute, but your machine learning pipeline can only process 200 within a minute, then you need something that can buffer all of these requests. And I have a video on buffering. So going to our example, if we delete these arrows, what's going to happen is this service, let's say responsible for machine learning, it's going to have some backpressure, all right? So it can handle less requests than this service can. And what the message bus helps us here with is it's going to be throttling all these messages so that the machine learning service can take its time and process these requests one by one as much as it can, all right? The next question would be, are these multiple teams or bounded contexts involved, or you can develop them independently? Meaning if team A has to coordinate deployments with team B every time, it's probably good to use a synchronous version and not asynchronous, or not an event-driven architecture. For example, meaning if deploying this service means that you also need to deploy this service because they're somehow interconnected, then this should not be decoupled. But if both of your services can grow separately and there are two different teams working on those two services, then they can actually be decoupled and an event-driven architecture can be used. Now, as a conclusion, and this is probably the most interesting part for you, if your flow is synchronous, meaning your actions are like a chain, one action has to happen after another one. Let's say the purchase has been made, you start a free trial, and only then you can send an email or something like this, then it's synchronous. Then the event-driven architecture doesn't pay for itself. Okay, this is gonna bring too much complexity. You can instead just use REST or gRPC and get away with that because it's gonna be much easier to debug your system. Because event-driven architecture introduces distributed system problems. For example, eventual consistency. I have a video on that, go check it out. You have to order the messages if you need ordering, obviously. You need to be idempotent. Also have a video on this because duplicate deliveries can sometimes lead to big problems. And schema evolution. So don't adopt these if one of these don't really fit your needs. But sometimes it's definitely worth it. And here are some examples. If the services are calling each other synchronously in a chain of 3 hops, meaning, for example, we have 2 services, obviously, right? But if we make a request to this service and to give a result, this service needs to call another service, right? And this service to give a result to this service needs to call another service. You can see that we have more than 3 hops. And in this case, you can actually make your architecture event-driven. Or for example, a fan-out smell would be that a service knows 6 other services that it has to contact when a specific action happens. Then this can also be fanned out. So a fan-out pattern can be used instead of making them synchronous. Or you have a monolith where one of the modules, let's say recommendation module of a specific product, is slowing down the whole system. Why not make it a good candidate for an event-driven architecture? Not the whole system, but specifically this recommendation part can be in an event-driven fashion. And then you're already gonna start breaking into microservices from just a monolith, so that you know. Now, if you learned something new, make sure to subscribe and smash like, obviously, and I'm gonna see you in the next one. Goodbye.